So in this lesson, we'll be learning how to solve polynomial equations. So basically these are equations where we have to determine x values that satisfy left side equals right side. And what these equations look like are going to be polynomials. Okay, so let's start off with the more simple example. Something like this. Here we have a polynomial in factor form and equals to 0. So we're trying to find solutions for x, numbers for x that satisfy this equation. Meaning, if we substitute a number for x for all of these, what should come out is 0. That's on the right side. So if you think about this, or I guess if we look at what we have here, what we have are three things multiplied each other right here. So these three things are multiplied each other, and we're trying to find out a number for x such that when we substitute a number into here, and then we multiply these three numbers, we get 0. Yeah, so that actually gives us a really good clue, because if you remember, anything multiplied by 0 is 0. So if one of these brackets, if any of these brackets actually equals to 0, so let's say if this guy, if we substitute a number in here, let's say this becomes 0. Oops. All right. So let's say we substitute a number in here. And then what came out was 0. It doesn't really matter what happens in the other brackets, what numbers come out. Since this is 0, and we're multiplying all of these guys together, these numbers could be like, I don't know, 8 or like 5. The result's going to be 0. So whatever number we substituted here to make this 0 would satisfy this entire equation. So this is actually really good, because then we can apply the same logic with the other brackets. So if we kind of erase all of this, if we substituted a number into our second bracket over, okay, I'm going to underline this again. If we substitute a number into our second bracket such that this bracket equals to 0, so this guy is 0, then it doesn't matter what numbers come out over here. The whole thing would be 0, the whole left side. It's like 0 times whatever number this is, times whatever number this is going to get 0. So this actually gives us a good insight into how to solve this. Basically, the solutions to this equation, the x values that will work, is going to come from each one of these brackets. We just basically need to make these brackets equal to 0. And the values for x that make these brackets equal to 0 are the solutions for our entire equation. So all we need to do is substitute x minus 1 equals 0, x plus 4 equals to 0. Yep, so the solutions to our equation is going to be when our bracket x minus 1 equals to 0, or if this bracket equals to 0, so if x plus 4, I guess we'll square it, or our third bracket, the number, this guy, equals to 0, so 2x minus 5 equals to 0. So then we have, if we solve each one of these individually, we have x equals to 1, this one is x equals to negative 4, and then this one is x equals 5 over 2. There we go. So here's our 3 solutions, and we solve this equation. Okay. So if you're looking at this process, and it seems fairly straightforward, since all we did over here was just set each one of these brackets equals to 0 and solve these much simpler equations individually. So what this means is, if we encounter polynomial equations that don't look like this, and there's going to be a lot of them, they're not going to look like this, but if we're able to get it so that it looks like this using algebra and what we know, then solving those more complicated equations is going to be a lot easier. So let's just take a moment and figure out what we need, like how we are able to do this so easily, like how we can set up a more complicated polynomial equation so that we can solve it like how we did it just now. Set up for solving polynomial equations. Yeah. So our polynomial over here is in factored form. So it's like we have all these brackets. Everything is factored. There's no addition or subtraction signs outside of these brackets. Just bracket, bracket, bracket on one side. So factored polynomial on one side. Okay, let's bold this. Okay. This. Okay. So ideal setup for polynomial equations. So we have something, a factored polynomial on one side, and we have 0 on the other side. So if this was any number like 1 or 3, we can't apply the same logic as we did over here. So we have factored polynomial on one side, 0 on the other side. So that's actually basically it, right? So that's all we need our polynomial to, all our equation needs to look like. So if we don't have something that looks like this, a factored polynomial on one side and 0 on the other, then we have to manipulate our equation using algebra and long division stuff, you know, to be able to do so. So the next example, we're going to take an example that doesn't look like this, something that's not factored, and we're going to solve it by looking at our ideal, knowing that this is our ideal setup, and taking the steps necessary to create this.
Okay. So here we have a more complicated example, meaning we don't have our ideal setup. We don't have 0 on one side equation and a factored polynomial on the other side. So here, as you notice, we have two polynomials that are not factored, they're in standard form. But we can use algebra and stuff to move stuff to the other side, and after we move stuff to the other side, we can factor it, and that way we'll have our ideal setup. So this is how we do this. So we are going to take these terms over here, and we're going to move them to the other side of our equation over here. That way we'll have 0 on one side. We're getting closer to our ideal setup. So x cubed minus x squared is 3x plus 30. And then we're moving all the other terms, so positive 17x squared, positive 6x, plus, minus 39. Okay, the next thing is we're just going to collect like terms. So we have 4x cubed, and then 17x squared minus x squared is positive 16x squared. 3x plus 6x is 9x. And then 30 minus 39 is negative 9. Cool. So we have 0 on one side of our equation now. All we need to do is factor this polynomial. Big question is how? So if you remember from our factor theorem stuff, we're able to factor our polynomial here by substituting numbers in our polynomial until we get 0. And that number that does it so, the corresponding factor to that number is going to be one of our brackets that we're going to write over here. It's going to be one of these brackets. So technically, we can choose a billion numbers to choose from, but what we can do is we can narrow it down to a pool of numbers that are possible factors of this polynomial. We won't be able to tell exactly which ones, but at least we can narrow our trial and error method to a certain collection of numbers that we choose from. Okay, so how we get this pool of numbers? Yeah, actually, we're gonna write this first. Okay, so how do we get this pool of possible factors? come from these two numbers. The very last number, so our constant, and the leading coefficient. So what we're going to do in our pool over here is we're going to write out all the possible factors of these two numbers that we circled. So for 9, all the numbers that multiply to get to 9, we have 1, 3, 9. I'm going to write the positive and negative versions of them because technically we can multiply like -3 with -3, with +3 to get -9. I'm going to do this. So 4, positive -1, positive -2, positive -4. Okay, so now they've written down these numbers, the possible factors that will work, or the possible numbers that we're going to choose from that are going to work, are going to come from all the different ways we can choose the numbers here for 9. And we're going to divide it by all the different ways we can choose 4, the factors of 4 down here. So what that means is our possible numbers here are going to be 1, okay, 1, positive -1 divided by positive -1, positive -3 divided by positive -1, positive -9 divided by positive -1. Let me write that over here. And then positive -1 divided by positive -2, and positive -3 divided by 2, positive -9 divided by 2. So notice how we're just all the different ways that we can match the factors of 9 with the factors of 4, and we're taking the numbers at the top and we're dividing it with the numbers at the bottom. Okay, so found a number that worked. So we're going to write that over here. So I actually found out when I plugged in positive 1/2, that equals 0. Therefore, we know that x, 2x minus 1 is a factor. Sweet, so now we know one of our brackets over here is going to be 2x minus 1. So the way we figure out the other bracket is, well, we know 2x minus 1 is going to be a factor. So all we need to do to figure out this guy is to divide our polynomial 4x cubed plus 16x squared plus 9x minus 9. Divide that with 2x minus 1 and we'll find the other bracket. So let's do that. And the way we do that is through synthetic division. And the way you can do this is either long division or synthetic division, whichever one is more preferable to you. I like synthetic because it's faster. Okay, so let's do this. 16. If you forget how to do synthetic division, don't know how, you can click on description. Click on one of the links to the left, the video on the left. Yeah. Okay. So this is actually not factorable. So how we can check what factors come from this guy is you can substitute it into our quadratic formula. So let's make some space for that. I'm going to erase this. So let's plug this into our quadratic formula. So it's x equals ab plus minus square root of b squared minus 4ac 2a. So after you plug it in, not squared. Okay, so I erased what we have over here. That way we have more room to continue solving this. So all we need to do is factor this quadratic now. And you can use crisscross or sum and product. So actually in my head we're gonna get 2x minus 1. Okay, these brackets. These guys would be 2x plus 3, x plus 3, 0. Okay, sweet. So now we have our ideal setup. And after this, now all we have to do is solve each of these simple equations. Just set each one of these guys, each one of these brackets equal to 0, and solve those equations. So we have 2x minus 1 equals 0, x equals 1 over 2, 2x plus 3 equals to 0, oops, x equals negative 3 over 2, 2x, not 2x. X equals to 3. And there we have it. Here are 3 solutions. And we are done. Yep, so basically, we just have to repeat this process. So basically, this is a process of how to solve polynomial equations. Doesn't matter how complicated it is. We just want to have our ideal setup. So we just move terms. We just move terms from one side to the other until we have 0 on one side of the equation, which we achieved over here. And then we want to factor our polynomial that we have over here. And the way we did that was we got all the possible factors which came from these two numbers, all the different ways, all the different factors of 9, divide by all the different factors of 4. And then we figure out one of our brackets. The next thing we did was we used long division to divide these two guys together to get the other bracket. And since this was a quadratic, then we can factor this without using synthetic division. We could just use crisscross sum product or any other method of factoring quadratics to get our ideal setup over here, a factored polynomial. Okay, and that's how you do it.